So have you ever really stopped to think about how we get these machines, which are incredibly powerful but also kind of dumb, to do all the amazing things they do? It's not just a tech question, really. It's a fundamental problem of communication. And the story of how we solve it is all about language and logic. Let's get into it.
You know, the author Ellen Ullman just nails it with this quote. When we're coding, we're not talking to a machine that thinks like us. Not even close. We're actually talking to a tiny, tiny slice of ourselves, that super focused part that's all about logic, order, and absolute crystal clear rules.
And that really gets to the heart of the problem, right? How in the world do you actually speak to a machine?
Well, at its most basic level, a computer only understands this wall of ones and zeros. It's pretty intimidating, right? What you're looking at is a simple program to add the numbers from 1 to 10. That's it. It's raw, it's totally unreadable for us, and it's completely alien to how the human brain is wired.
Okay, so what if we translate that binary into English? Well, it's still awful. It's this super tedious process of store this number here. Okay, now store that value over there. I mean, it is just a recipe for disaster and headaches. Can you imagine trying to build something like, say, a social media app this way? No chance.
And right here, the solution just snaps into focus. On the left, you've got the machine's language. On the right, you have JavaScript. It just says console.log sum range 1 to 10. It's so clean, it's practically English. This gigantic gap is bridged by what we call a programming language.
So, to fix this massive communication gap, we had to do something pretty clever. We had to invent a brand new kind of language.
At the end of the day, a programming language is just a special vocabulary with its own grammar. But its real magic, its superpower, is that it handles all those boring, mind-numbing details for us. It lets us, the humans, focus on the big picture, the actual problem we're trying to solve.
And just like any other language, it's got its basic words. You have numbers for doing math, you have strings of text for, words, and you have booleans, which are basically just a simple true or false. These are the atoms, the fundamental bits of information that we use to build everything else. Okay, but that brings up the next big question. If we start building bigger things, how do we keep from just repeating ourselves a million times? How do we stop our programs from turning into a complete and utter tangled mess?
Well, the answer is a really powerful idea called abstraction. It's all about creating reusable building blocks.
So, the first and maybe most important building block is the function. The best way to think about it is like wrapping up a bunch of instructions and giving that whole package a single name. It's like, instead of describing the whole scientific process every time, you just say the word photosynthesis. A function lets you invent a new verb for your language.
And if functions are our new verbs, then objects are like specialized toolkits. They let us bundle related data and functions all together in one convenient place. So for example, if you need to work with a user, you can have a user object that holds their name, their email, and even the function to send them a welcome message all packed together.
The great computer scientist Donald Knuth described this whole process perfectly. He said, programming is just many people doing things that build on each other, like a wall of mini-stones. It's not about one genius having a flash of brilliance. It's about each person adding their own small solid stone, a function, an object, to a much larger wall.
So how do we actually combine all these little building blocks? Well, we scale up. We move from thinking about individual blocks to creating entire blueprints for our software.
And this is where it gets really elegant. We can use functions to process other functions. Check out this data pipeline. You start with a big list, then you filter out what you don't need. You map the rest to transform them into something new. And finally, you reduce it all down to a single answer. It's like a data assembly line. It's clean, it's powerful, and it's surprisingly easy to read.
But what if somebody else already built the perfect mini stone that you need? Well, that's where modules and packages come into play. They're basically just standard ways for programmers to bundle up and share their building blocks. And a service like NPM is like a gigantic public library or an app store for code, which means we don't all have to rebuild the same wall from scratch every single time.
All right, so we've gone through all this theory, but where does all this code actually live and run out in the real world?
For JavaScript, it's mainly two places. First, in your web browser. That's where it handles all the interactivity, the clicks, the forms, and it does that by manipulating something called the DOM, which is basically the structured layout of the web page. But it also runs on the back end, on servers, using a thing called Node.js.
And that's where it deals with files, databases, and all the behind-the-scenes networking stuff.
And all of this leads us to a really deep insight about software from CAR Hoare. He said there are two ways to build things. You can either make it so simple that there are obviously no problems, or you can make it so complicated that there are no obvious problems. And really, this whole journey from that messy binary to elegant code has been a search for that powerful simplicity.
And that leaves us with one last thought. We've seen that programming isn't some dark art. It's really just about breaking down huge, complicated problems into small, manageable pieces. So the real question isn't, can you code? It's, what complex problem out there could you start solving, just one mini stone at a time?